Hi, this project's basic idea is based on a mobile application Cloud9 which is to be installed on a user's device before the event of the disaster. The aim is to tackle the critical problem of lack of mobile network connectivity which can be partially restored by creating virtual networks. Suppose we have mobile network towers covering some area and some nodes connected to it. Here, a node means a high population density area. Now, if a disaster strikes and one tower goes down, some nodes will be disconnected from the network. Using machine learning classification techniques and with the information of disconnected nodes, we can classify the area which has lost mobile network coverage. These nodes may move randomly in any direction and it will be hard to predict their location. Suppose these nodes had their own network and could communicate among themselves. They would have gathered at a spot which is least affected by the disaster. Now, the rescue team can send a drone to search where the nodes have gathered and establish a connection between the nodes and the base station. Once the network has been established, supplies can be sent using the drones till the nodes are rescued. Now, let me explain you what I exactly mean by a node. Suppose these blue dots are the locations of the people which just got disconnected. Now, using Azure Machine Learning and Azure Maps, I can classify them into different groups. After classifying them into groups, I'll send my drones which have USRP or microcells to create a local network. Now, every node is a local network and every node will act as a router on a bigger network. Now, let us move on to the user point of view of the app, how the user will perceive our Cloud9 app. The app will function in two modes, the normal mode and the disaster mode. In the normal mode, the app will show weather data for different cities. This functionality is to keep the app installed in user's device before the disaster strikes, as it may be the case that the user is not able to install the app after the disaster. It also sends disaster alerts using weather prediction. In the disaster mode, the user has options like disaster guidelines, safe map, and a chat room. In disaster guidelines section, the user can see the guidelines for different disasters. For example, suppose there is a cyclone. The user can see what to do before a cyclone, during the cyclone, and after the cyclone. The user also has a functionality of safe map. In the safe map, the user can see the location of the nodes connected in its network. For example, this is person A in a user's network, this is person B in the user's network, and this is the current user. And this location is a safe spot. Now the user can also find directions for the safe spot. Now, to communicate between the members of his node, the user can use this chat room. We'll be using Microsoft Azure Machine Learning and Microsoft Azure Maps for our backend computation. Some of the features of the app are still not fully implemented.